Hello friends, welcome you in my YouTube channel. I am Dr. Mohammad Sirajul Akfaisi, Assistant Professor, Department of Chemistry, LS College, Muzaffarpur. Today in this video, I am going to explain about sulfur. So, if sulfur is present in organic compounds, there are different types of functional group will form. First look at it here. If S, this is sulfur and this is hydrogen, so this functional group is known as thiol. This is also thiol. You see SH, this is thiol. Now you have heard about sulfone. You see sulfur double bond oxygen, sulfur double bond oxygen. This is the sulfone functional groups present in Dapsone water soluble prodrug for leprosy. And sulfide SO3 minus, here sulfur SO3 minus, this is known as sulfide. Again you see the sulfonamide, C S double bond O, S double bond O, sulfone groups. Now it is attached with the nitrogens. Here you see a very good compound, glutathione, a scavenger of toxic oxidants. Thiol group is present. Sulfur is present in most important antibiotics, penicillin family. So these compounds contains the sulfur. Now look at the sulfur, how it is working. So if you have sulfonate ester, you see S double bond O, S double bond O, here O. So paratoluene sulfonate, this is sulfone and it becomes sulfonate. So thiolate, pH SH, now pH S minus, act as nucleophile. So thiolate anion attack on this carbon, and meanwhile carbon oxygen bond will break and forming sulfide. You see PHS and CH3 sulfide, and this is the sulfonate salt, sulfonate salts. Now look at here, this proton is acidic, so if you add the base, then it become carbon ion, sulfone stabilized anion. You see the sulfone is double bond oxygen, and then it react with aldehyde and acid medium, forming this compound. Again here dehydrations from this position and this positions, which will remove and forming carbon-carbon double bonds. Now sulfone, sulfoxide and sulfides, that is the importance. Sulfone, sulfur double bond oxygen, sulfur double bond oxygen, sulfoxide, sulfur double bond oxygens, and sulfide without oxygens. So it reacts with butyl lithium, forming, you see, lithium attached by removing this proton, and same way here and same way here. Now it react with this compound, and then you see it attack on carbonyl, carbon here, and meanwhile this bond will break and forming 70% yield. Nice yield. Now this, you see, attack on this and forming this compound. Trimethyl silyl chloride attack on this and forming this compound. So now you understand methyl. First with the bully they remove the proton, and then this compound will attack on carbonyl. So basic facts about sulfur. You see the crystalline sulfur, you learn from the beginning. Now you see the oxidation state, H2 minus, RS minus, R2S, R2SO, SA4, and so on. So focus on sulfur is very versatile elements. This is thiol. Now it reacts. So you see, in presence of sodium hydroxide, these H and Br will remove and forming these products. So formation of sulfur carbon bonds. Here SH, you see, S minus attack on this carbon. This is SN2 reactions. So this is the mechanism. So thiols are more acidic than alcohols. I repeat, for net examination, thiols are more acidic than alcohols, but sulfur compounds are better nucleophiles. But sulfur compounds are better nucleophile than oxygens. Better nucleophile than oxygen compound toward saturated carbon atoms, SN2 ratio. I repeat, sulfur or thiols are more acidic than alcohol. This is more acidic than alcohol, but sulfur compound are better nucleophile. Now look at this sulfuryl chloride. You see the sulfone, and now it is attached with the chlorine, and here chlorine. We call it sulfuryl chloride. Sulfuryl chloride again disulfide, sulfur single bond. Here these lone pair of electrons approaching this chlorine, sulfur chlorine bond will break and this bond will shift here, and meanwhile sulfur double bond oxygen becomes single bond. So sulfonium salt formations. You see sulfur attached with carbon and chlorine. Sulfonium salt, and you look at here, and again it is rearranging, forming sulfur dioxide and chloride. So you look at here. This is very important examples. If you have the double bonds, it approaches to sulfur, and meanwhile sulfur chlorine bond will break and forming cyclic sulfonium salt, and after attacking chlorine this bond will break and forming these compounds. So look at here, zinc have lone pairs, it attract this chlorine forming this, and two ways of drawing a sulfonate ion. This is sulfonate ion. Either sulfur contains negative charge or either oxygen containing negative charge. So sulfonate anion, this anion, now it approaching to this center, and meanwhile carbon bromine bond break and allylic sulfone. You see this is allyl, this is sulfone. Allylic sulfone, this compound will forms. So sulfur compound are good nucleophile and good electrophile. I repeat, sulfur compounds are good electrophiles and nucleophiles. Sulfur compounds are good nucleophiles and electrophiles. So sulfur based functional groups, look at thiols RSH, thiolate anion RS minus, disulfide RS SR, sulfinyl chloride RS Cl, sulfide RSR, thioether, we call it thioether also, sulfonium salt R3S plus, sulfoxide R2SO or R2SO plus or minus, sulfone R2SO2, sulfonic acid RSO2OH, sulfonyl chloride RSO2Cl. So these are the structure of functional groups, and examples you see, smell, taste of coffee and a lot. So sulfur stabilized anion, you see methyl phenyl sulfide, sulfur contains two lone pair of electrons, methyl phenyl sulfoxide, one lone pair of electrons, either this way or this way, methyl phenyl sulfone, you see the sulfone. So enantiomers of chiral sulfoxide, if you look at here. Now if you have the S double bond O, so if you add the base, this alpha carbon, you see CH2 like the CO groups, and then it react with the lithium and forming CH2 lithium. So if you have the methane, if you have this compound, this compound, this compound, this compound, so pK measured in DMSO is different. So now sulfone structures, probable conformation of sulfone stabilized anion. You see this carbon contains, sulfur contains two CO bonds, and this carbon have the negative charge. So any base will trap this proton and forming planar enolate. Now the same way, here carbon double bond oxygen, here sulfur double bond oxygen approaching this and forming this anion. So friend, I will talk further on this topic, on sulfur, in next video. Hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.